Hello, everyone. Make sure that you have downloaded the document from Canvas, the notes on non-renewable resources. And as we're going through this video, you should write everything down on that document. So you will find that there's a lot of videos attached to this PowerPoint presentation. And the links for those videos are in the document. So you can just press Control. Well, I'm on a PC, so maybe it's different on a Mac, or a Chromebook. Press Control and then click on the link, and it should open up in your browser. And as you're watching the videos, there's a box where you will take notes on what you've learned, and then also questions, comments, connections that you make. So let's get started. And, as usual, you can pause this video when you need to write things down. You can listen to it a second time if you need to, and just take your time getting through it. So I want you to think about all the things that we mine. So things that we take out of the ground. And here's just a diagram looking at one child, and in their lifetime, a typical person will use almost 3 million pounds of minerals, metals, and fuels that have been mined out of the ground. Amazing, huh? That's American. That would be very different for people living in some other countries. So elements that make up the crust of the earth, here they are. Lots of different elements, mostly oxygen. And we're going to talk about just a very small portion of these metals that we mine. So some are aluminum, they're quite common, iron, but there's a lot that are very uncommon. And because of that, it can be very expensive to get to them, and they're valuable because they are uncommon. And this is a short list of things that we mine for, but there are many, many things, or things that would be components of items that you buy, like your cell phone has a lot of elements, just small amounts of each one, but a lot that are mined out of the ground. I'd like you to watch this short video about extraction and what a big deal it is to pull all these materials out of the ground. So mining is very, very expensive. It requires a lot of money because some of the technology is expensive. It takes a lot of time to identify where in the earth some of the materials that we mine for are located. And then they can be very deep underground, and moving all that earth is expensive. So in order to try to make it a little less expensive, the US government made a law a long time ago. It's the General Mining Law of 1872. And believe it or not, it is still in effect. It has never been rewritten. Other laws about mining have been written, but this is still the law of the land. And it was written because mining is so expensive. The startup costs are huge. So they wanted to make at least acquiring the land for mining less expensive. So this is how inexpensive it is. And this is still the cost today. $2.50 per acre of US public land for an open pit mine. It's $5 an acre for a vein of material. So that is like a strip of whatever you're looking for under the ground. And those claims don't expire. It's amazing. And in addition to that, there's no royalties that have to be paid by the mining company. So a royalty is a a percentage of the money that they make would go to the government, but they don't have to pay anything. Amazing. And if you don't believe me, then I'd like you to watch this National Geographic video about the general mining law. So there are lots of issues with this law. First of all, that they don't have to pay any royalties to taxpayers. So this is mines created on U.S. public lands, and yet the companies can make all the money and not pay anything to the owners of the land, the taxpayers. And back in the time when this law was written, people really didn't think about protecting the environment. So the mining law doesn't have any environmental protection provisions in it. And mining gets priority over all other uses of the land. Even if there's a good other use, it doesn't matter. Mining will get priority. And today, we have hundreds of thousands of abandoned mines. If we were to clean all of those mines up, the low estimate would be $32 billion to clean it up, and the high estimate, $72 billion. Who would pay for that? The taxpayers, for the most part. Now, to try to repair some of the damage with mining, back in 1977, the 70s were a great decade of laws written for protecting the environment. And one of those laws is the Surface Mining Control and Reclamation Act. And so this regulates the effects of surface mining, only surface mining. And it does set some environmental standards. The general mining law doesn't have any environmental standards, but this does. And it's really around acid mine drainage, reducing erosion, and protecting waterways. Those are three of the major issues with mining, and we'll get into each one of them coming up. So it does require that companies obtain a permit in order to mine, and they must post a bond. So that's money that they put into an account with the US government, and it's supposed to cover the cost of reclamation, so fixing the land after they're done with the mining. And then a government agent will come in once a month to inspect the mine. And it does restrict some surface mining on certain lands. So they can't mine in the national parks and wilderness areas, but other public lands are still open for mining. And if you're wondering about how much land we're talking about, it's a huge amount of land. The public lands that are managed by the Bureau of Land Management, it's about a quarter of the U.S., the vast majority of it in the western United States. So before we talk too much more about mining, you need to know some of the terms that you're going to hear. So one term is the overburden. So that's the rock in the soil that's lying on top of the mineral deposit. So you've got to move that out of the way so you have access to whatever you're going after. And it can be a tremendous amount of land, and you have to put it somewhere, right? So this takes a lot of space. So once you move that soil, you have to put it somewhere. And what we call that is the spoils. So the overburden has been removed, and once it's all this waste rock, that is called the spoils. And you can see these piles of spoils. So the overburden was removed and made into these long piles. And one thing you have to keep in mind is this is soil that was so deep. There's no topsoil there. So when this recovers, it's primary succession, which takes a long time. So think back to ecology, primary and secondary succession. Remember, for secondary succession to occur, there must be soil. Well, this mining, there was soil on top, but that just got buried under all these spoils. And now it's going to be primary succession that has to happen for this area to recover. The tailings, that's after some processing has occurred. So the valuable part that they're going after has been separated from the uneconomic part, just the rock that is useless. And those mine tailings, along with the spoils, have to be dumped somewhere. The gangue, that's pronounced gang, that's even more waste rock. So you've separated the valuable part from the tailings, and that's the ore. But mixed in with that is some worthless material that you still have to separate. So hopefully you're getting an idea of, number one, the huge amount of fossil fuels that go into mining to move all of this material around, and then the vast amount of material that is just in the way. They're going after whatever the metal is, or diamonds, or whatever it is. And there's a huge amount of material that they had to move for that. And that gets placed somewhere. And then that land has to recover some, which is going to be primary succession. So some of the different techniques that are used for mining, there's two major ones. There's surface mining. That's for about 90% of the minerals and 70% of the coal. And then there's subsurface mining. That's when the coal or whatever mineral they're going after is deep underground. Then they'll usually use subsurface mining to get to it. So here's a video for you to watch with some mining basics. And some of that terminology that I just went over with you, you're going to hear about it in this video. So watch this and take notes on your paper. I'd like you to see this graph of mining productivity. It's gone up a lot. The technology has improved. Some of the materials are worth more money, so the companies are willing to go deeper underground and spend more because they're going to make more. And there's also more mines today than there ever have been. So productivity has gone up a lot in both underground mines and also surface mines. Now, there's a lot of pros and cons to both types of mining. And there's a table on your document where I'd like you to write down some of the pros and the cons. So surface mining, it disturbs a very large area, moving all the overburden, the tailings, the spoils. It's a lot of disturbed land. But it is relatively safe for the people who work there. Maybe not for the communities around it, because there can be a lot of air pollution and water pollution. But for the workers, it's safer. It's much cheaper, and it's pretty efficient as well. But it produces a very large amount of spoils that are left on the surface, and then that land has to recover, which is a very slow process. Now, subsurface mining, it does disturb a smaller area, but it's very dangerous for the workers, right? Better for the communities around it, but dangerous for workers. It's much more expensive as well. And it also doesn't recover as much material, so it's less efficient. The good thing, though, is a lot of those spoils are left underground. So we don't have so much disturbed land and the primary succession that has to occur with it. And I want you to have a view of what this mining looks like. So this is an open pit mine in New Mexico. Actually, if you've ever driven on a road trip through, the Southwest, and actually farther north as well, you'll see lots and lots of mines. Some of them abandoned, some of them still working. This is one of the biggest copper mines in the world. This is area strip mining in Nevada. And so hopefully you can see just how large this is and how much area is disturbed just to go after some gold. This is contour mining, where they follow the contours of the mountain. And it leaves some scars, but there's certainly worse ones, which you'll see. This is mountaintop removal. So they actually will remove the entire top of a mountain going after coal. So you're going to watch some videos about this and learn more about mountaintop removal. So I'd like you to watch this movie from PBS. It's not a movie. This show, NewsHour show, about mountaintop removal, and take notes on your document. Now, subsurface mining, there's different types, and it kind of depends on what they're going after and what mineral or what fossil fuel, and also what the terrain is like. So it can be a shaft mine, so it goes straight down, and then a horizontal shaft is drilled, and they're going to follow a vein of material. So in this picture, it's coal, but it could be, some other kind of metal that they're looking for, some other material. It could be a sloped mine. That's another possibility. So it's not straight down and then to a shaft, but it's a slope. Or if they're on the side of a mountain, it can be a drift mine where they're just going straight in sideways. So you can see some of the issues around surface mining. Watch this video and take notes on your document. One of the biggest issues with mining is acid mine drainage. So watch this video and take notes about acid mine drainage. And all of that acid mine drainage can really cause a lot of problems. And this is a terrible spill that occurred in Colorado, and it affected water from numerous states. So watch this video and take notes. So a little bit more about acid mine drainage and what causes it. This is one of the major issues with mining. A lot of the rock that contains useful metals that we're mining for, they also contain sulfide minerals. And those minerals combined with metal and sulfur. So this picture is showing the sulfide minerals in the rock. So one of the most common one is actually really beautiful. It's pyrite. It's sometimes called fool's gold because people would mistake it for gold, but what it actually is iron and sulfur together. And you can tell that it's not gold because it's got these faces on it. It forms crystals with faces, and gold doesn't do that. Also, you can drop acid on it, any kind of acid, like vinegar would do it, and it'll smell like rotten eggs, hydrogen sulfide. And so this is a very, very common material in the rock, so especially near the metals that you're looking for underground. So wherever you're mining for metals, you are very likely going to have high amounts of sulfide minerals in the rocks. So, and here's what the problem is. When those sulfide minerals come in contact with oxygen in the air, when they're buried underground, they're not coming into contact with much oxygen. But as soon as they're brought up as spoils, as tailings, as gangue, then all of a sudden they're exposed to the air and also water. And that's when they get oxidized and they turn into this rusty iron oxide along with sulfuric acid. And then there's also bacteria in the soil that make this process go a lot faster. And when those bacteria are buried deep underground and not near oxygen, not a problem. But you get the bacteria exposed to air, and the bacteria can make this process a whole lot faster. So that sulfuric acid that's produced by the sulfide minerals coming in contact with water and oxygen, they get into the water and they get into the soil, and they can pull, the acid will pull toxic metals out of the rocks and the soils around it. So the metals would normally just stay in the soil and the rocks, but when there's an acid there, the acid will get those toxic metals into the water. So acid mine drainage it's bad enough, but it also goes along with toxic metals, and those can drain into waterways. And then the other big environmental issue is erosion. And I showed you those pictures of different mines and all that rock that's been dug up, and now it can get blown away by the wind. When it rains, it can get washed away. So between erosion, acid mine drainage, and pollution of waterways, those are the biggest issues with mining, and they're huge issues. So old mine sites are worse than newer mine sites because we do have better environmental protections today than we used to. But it's a very big deal cleaning up after a mine. So I want you to watch this video and take notes on your paper. Some of the health effects of coal are really important to know about. And one thing you may not be aware, a lot of coal gets shipped to Oakland, put on ships, and shipped out to Asia. So we here in the Bay Area, we also have these health effects of coal. And Richmond is another place where a lot of coal gets shipped out. And notice it's often poor communities where the coal is shipped. So the poor people are dealing with the worst health effects. So you know about mining for precious metals and diamonds. Here's another video for you to watch. One thing that happens in a lot of countries is illegal gold mining. And the pollution, the environmental degradation, the health of people, the health impacts, it's huge. So watch this video about illegal gold mining in Peru. But Peru is not the only country. Keep that in mind. A lot of countries where they don't have the best environmental laws have the worst problems, although we have had our fair share of mining problems in our country too. But this was a dam that collapsed in Brazil. So this was a dam holding back water used in the mining process. So a little bit about how the metals are separated from the rock. And this is, again, a very, causes a lot of greenhouse gas emissions from the fossil fuel use, and also causes a lot of water pollution and air pollution. So watch watch this and pay attention to those things. So you're looking at greenhouse gas emissions, water pollution, air pollution. So the first thing is the ore. So that's they've removed the spoils, the tailings, the gang, and now they've got the ore. So that's the rock that contains the metal, but it's still got to be separated some more. That was not supposed to happen. Let's see, where are we? So there are facilities that grind the ore down into small particles. So look at the size of that factory and all of them grinding rock particles, the rock that contains the metal that they're looking for. After grinding, then they separate the material. A lot of times they use water, soapy water. And so they're agitating it in these huge vats. So that means stirring it around, and they can separate the rock from the metal that they're looking for. And so think about the amount of water pollution and also the fossil fuels that go into this. There's some metals that can be separated by percolating liquid down. So they'll spray a liquid with chemicals in it, and that will dissolve the metals, and then it's called leaching when that liquid runs through the soil and carries away, in this case, the metals. So they do this a lot with gold. So I want you to think about all the water used in this. So first of all, the fossil fuels for all the equipment to bring all this material to the surface. Now all the water that they're spraying on it, along with chemicals, and you can start thinking about, again, water pollution, fossil fuel use, and some of this will get blown away and cause air pollution. Now, some materials have to be heated up. So this is a smelter where they heat it until the metal separates from the impurities. So lots and lots of fossil fuels to heat it up so much, as well as all the equipment. And there's a huge amount of air pollution that goes into this. So as they're heating up the ore, the metals separate from the other minerals, but you end up making a lot of air pollution. And then finally, the molten metal is poured into molds and solidifies. And then it can get shipped to wherever it's needed to maybe mix with other metals and to fabricate whatever we are buying. At some point, a mine is going to be just economically not useful anymore. It's too expensive to pull out any more material. And at that point, it has to be reclaimed. So there's various things that they want to do. The main things they're trying to avoid is those sulfide-bearing rocks, remember, that cause the acid mine drainage. They want to cover those with soil so they're not exposed to the air and the water. They also want to stop erosion by planting plants on the bare soil, and also protect waterways. And sometimes that's by neutralizing the acidic conditions from those sulfide-bearing rocks. And so one thing that's proven very useful is constructing wetlands. So that can remove some of the metals. Some plants can do that. And they can protect those sulfide metals from coming in contact with the water, with the water and the oxygen. Did it again. Sometimes they have to add treatment plants to deal with all of the acid mine drainage and also other chemicals, like some of those toxic metals that the acid will leach out of the soil. And then somebody has to maintain that water treatment facility. Okay, a couple more videos for you to watch. We didn't really talk about fossil fuels very much other than coal. So watch this video about how we pump oil and take notes on your paper. And another technique that you're hearing more and more about is hydraulic fracturing, usually called fracking. What a terrible name. Who thought of that name? So there's a video for you to watch so you can understand what fracking does. And this is usually to collect the gases that are around an area where fossil fuels are located under the ground. In Canada, they are collecting fossil fuels out of tar sands. And this is a really water intensive way of getting fossil fuels. Uses a lot of fossil fuels to collect it because it has to be heated. Huge amounts of land disruption and water use. So watch this video and take some notes. All right. So I will see you back in class. Thank you for your time.